Let's look at homework number 4. All right, I will video this as well as put the answer key or take pictures of this and post this on Blackboard as well for you. I hope it's helpful. 2020. So please go back and at least maybe double check your answers versus the answer key. Hopefully it'll help you out some. It says here that a ball will roll off the edge of a cliff. Again, some of us, I see us having problems on the quiz. I see you having problems on the homework. But again, I'm not seeing any drawings happening. Here's a ball. It's rolling off of a cliff. Okay. As it rolls, it has a velocity because it's moving this way. It's going to fall off like this. It takes 10 seconds for it to reach the ground below. So while it's in the air, T equals 10 seconds. The next step that you're going to do is you're going to X and Y component, because I see a parabola was formed. X and Y. DTV, DTVIA, and then yes, VF, but it's not even used. A is 9.81. VI is 0. T was 10 seconds. D was not given to me. D was not given. T is 10 seconds. And V was not given to me. So now I have my X and my Y components filled in. How tall is the cliff? Okay. Well, I guess I started writing things in before I read the whole thing. The question is, from here to here, how tall is that? I'm going to put a question mark there. Let me grab my highlighter. What side am I looking for? I am looking for the Y component side. In your notes, it tells you that when it comes to the Y component side, there is an equation that we're going to use. D equals 1/2 AT squared. This is going to work 90% of the time. Again, there are a few times where it may not work, but 90% of the time, this is going to be the one that works. Let's try it. D, 1/2, I'm going to convert to 0.5. 9.81, yes, I do know it's a negative because it's going down. And T is, they told me 10 seconds, and I need to square it. Okay. Let's go ahead and do that. Let me square this 10 first and make that 100. So 10 squared times 9.81 times 0.5 equals 490.5 meters. Yes, it's a negative value because it's falling down. That is the correct answer. This was a one-step problem. The majority of the parabola problems are two-step, but this one was a one-step problem. Number 2. A wheelchair ramp is 4.2 meters long. It rises 0.7 meters. Okay, so let me start off with, here's the ground, and here's the wheelchair ramp. The ramp is 4.2 meters long. 4.2 meters. How high up does it rise up? It rises from here to here, 0.7 meters. What is the angle of the incline? Right here, question mark. What is my theta? I see that this produces a right triangle. So I'm going to find my right angle. I get this right angle, or this box, I draw a line to the opposite side, and that is my hypotenuse leg. The theta and the right angle are my adjacent leg, and what's left over is my opposite leg. I'm going to go ahead right here and write so, ka, toa. Alrighty. Pull this white out this highlighter throws off what I'm doing. right? There we go. Now I'm going to get my highlighter and I'm going to highlight what I have. I have this leg, the hypotenuse, and I have this leg, which is the opposite. What am I looking for? I'm looking for the theta. Not a problem. So the H and the O. Who is H and O? The sine. So the sine of the theta equals O over H. Or the sine of the theta equals 0.7 over H 4.2. So 0.7 divided by 4.2 comes out to 0.167. That is not my answer. Just like we have square and square root, this is not the actual theta. I need to do the opposite of the theta, which is an inverse of that, which is a -1. That -1 key is the second key on your calculator, and then sine. So second key, sine, 0.167, close parentheses. The theta actually equals 9.61 degrees. Now, please don't forget, you can come over here too. You should go to mode, click that, and check to make sure you're in degrees. My degrees is highlighted, so I'm good. I'm going to click clear. If it's not, you can scroll down, go sideways, hit enter, and then clear. But you must be in degrees. Alrighty, let's keep going. The next question here is a golf ball. It's hit off of a ledge. Alright, here's my ledge. Here's my little tee. Here's my golf ball. What is the vertical speed of the ball? Because, right, it's hit off the ledge. What is the vertical speed, question mark, velocity of the ball? If the ball is after 15 seconds of being hit, it's going to form a parabola. Okay. And they told me t equals 15. Well, when I see a parabola, what do I think? X and Y components. DTV. DTVI AVF. Remember, 90% of the times we're not going to need the VF, but you know what? It's part of it. Why don't we just go ahead and write it down? You never know when you need it. We are looking for, look at this, the horizontal velocity, which is the X component. I'm going to put a question mark. The T, they told me, was 15 seconds, and that variable can go on both sides. Everything else is independent of themselves. I'm sorry, I did not mean to question mark the distance. I meant to question mark the velocity. That was not given to me. Was this given to me? No. VI I know is 0, 9.81, and VF was not given to me. Well, what side of the equation am I looking for? Well, I'm looking for this X component side. So I'm going to go ahead and highlight that. That's what I'm looking for. All right. So I'm looking for the velocity here. What is the vertical speed? Oh my goodness, I can't believe I feel like I screwed this all up. My brain is not working today. And what did I do? I wrote the horizontal speed as my question mark. I know that there's a horizontal speed. That was not given to me. My vertical speed is what I'm looking for. Where at? Is it the first vertical or is it the second? If I know that, if I already wrote down VI as 0, then I'm looking for this final velocity at 15 seconds. So let's pretend at this location right here, that is T15. 15. Well, what's the velocity at that location? And that would be my v sub f, question mark. Okay, I know my vi before it falls down is 0. So in this case now, 90% of the time I told you we're going to, when we're looking at y components, d equals 1/2 at squared. But does that have anything to do with the VF? No, that's not going to help me. Okay, so this is the one rare occasion I'm going to need to find another equation to use. So in this case, I'm going to come around and I'm going to use A equals VF minus VI over T. Do I have the A? Yes. Do I have the VI? Yes. Do I have the T? Absolutely. I can rearrange this or algebraically solve it and find the final velocity. So 9.81 equals VF minus 0 over, what was T again? 15 seconds. Well, let's get the 15 from the bottom, bring it up to the top, multiply by 15, cancel, and multiply by 15. Okay. Subtract 0 is not going to do anything. You know what? Add 0 on both sides, that's nothing, so that cancels out. So 15 times 9.81 equals a final velocity of 147.15 meters per second. Okay? We talked about setting this up. Hopefully you did set it up. Hopefully you tried it. Please go back and double check your answers and see what you got. Okay? But we wanted to know the vertical speed of the object, not horizontal, so we were looking for the downward direction, not horizontal. Let's keep going. We talked about this one and did this one already. The same picture was on your quiz for some of us. We had different quizzes. But remember, all of them are going to hit the ground at the same time. Why? Because it's the same height. What determines the amount of time that that object's going to be in the air? The distance that it is falling. Okay? If it has a higher distance, it's going to be in the air longer. If it has a shorter distance, it's going to be in the air for a shorter amount of time. Next one over here. This table is just really the T chart that we do with our components. A ball rolls off of a table. With a speed of 2 meters per second. That is 1 meter above the floor. How far along the floor is it going to land? Question mark, horizontal. Again, I like my T chart, so I'm going to fill it in. I will fill in this table. DTV. We are looking for the horizontal distance. The T was not given to me. The velocity was 2. DTVIAVF. This was given to me as 1. T was not given. VI is 0 in the vertical component direction. A is 9.81 and VF was also not given. Now I can go ahead and fill this in. Vertical, which is the Y. Horizontal, which is the X. So the height was 1 meter. G, which is the same thing as A for gravity, 9.81. And T was not given to me. In the X component, the distance is my unknown. The T was not given to me, and the speed or velocity was a 2. Okay, now going back to my highlighter, what am I looking for? I'm looking for the X component. That is my unknown side. Do I have enough information to answer? No, I do not. I'm missing two variables. It means I'm going to have to come over here to the y component, solve for t, plug it in here, and then find the distance. And we can do that. It's a two-step problem. Step 1, what is the equation 90% of the time we're going to use? D equals 1/2 AT squared. 1 equals 0.5 times 9.81 times t squared. Divided by 4.905. Cancel. Divide by 4.905. I got a t squared of 0.204. That's not my answer because I need to square root it. So t comes out to 0.452 seconds. I'm going to come over here and fill that in. 0.452, 0.452. Now that was just part 1. Let's do the second part, which is the x component equation. D equals V times T. Okay. D, I do not know it. V is 2. T is 0.452. Multiply those numbers. I get a distance of 0.903 meters. I hope this helps out a little bit, okay? Let's turn the page and let's keep going. The next page looks like this. Let's read the question. The angle of elevation of the sun is 68 degrees when a tree casts a shadow. Okay. That is 14.3 meters long. How tall is this tree to the nearest tenth of a meter? Remember, we started this process already, and we looked at it, we talked about it. I even tried to set you up, okay? So, the angle of elevation, first thing is, I would draw this out. I understand it's not easy when reading it. It looks very kind of weird, wordy, okay? But when we draw out this tree, it casts a shadow. Here's my tree. Here's my shadow, right? Because your shadow is on the ground. You agree with that? Here's the actual tree. And there's the shadow of the tree. What does this produce? A right angle. Okay? The sun is obviously somehow the angle of elevation of the sun. So maybe the sun elevation is coming up, right? So here it is. The sun is coming up. I mean, I can draw this triangle the other way if need be. It would still be the same answer, whether I drew this triangle this way or whether I drew it this way. Okay, it would just be flipped. This is my theta. They told me that the shadow is 14.3 meters long. The theta is 68 degrees. How tall, question mark, is this tree? First thing I think is SOHCAHTOA. I'm going to come over here and label. This is my right angle, so this has to be my hypotenuse. If this is my theta and right angle, then this is my adjacent leg, and this is my opposite. With my highlighter, I'm going to say, what do I have? I have the adjacent leg, and I'm looking for the opposite leg. O and A. Who is O and A? Tan. So the tan of the theta equals O over A. Or the tan of 68 degrees equals O over 14.3. We're going to use our algebra to isolate O. So multiply by 14.3, cancel. Multiply by 14.3. Make sure you're in degrees and not radians. So the tan of 68 degrees equals times 14.3 equals 35.39 meters. Let's keep going. The chart here. Okay, so on this chart, here is the actual time. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And what we were seeing here was we have, let's just say, a person on this super tall cliff. Ooh, that's pretty tall. And they're way up here. And they have this rock object, something, and they're going to let it go. And at the first second that it is falling, where is the location? What is the velocity and what's the acceleration of that object? At the second that it is falling, what is the distance, what is the velocity, and what is the acceleration? And that's what they're asking you. So let's go ahead and let's fill this in. Distance equals 1/2 AT squared, which is what we've been using this whole time. I'm going to change the 1/2 to 0.5. 9.81 times 2 square. 2 square is 4 times 9.81 times 0.5. You should get 19.62 meters. The next one, 0.5 times 9.81 times, we're going to plug in 3 square equals 40. 4.1, I'm going to round up to 5 meters. Let's keep going. 0.5 times 9.81. And again, what is this right here happening? This is a vertical direction. We are using the vertical component equation. 4 square equals 78.48 meters. 0.5 times 9.81 times 5 square equals 122.62 meters. 0.5 times 9.81 times 6 square is 176.58 meters. Let's keep going. 0.5 times 9.81 times 7. Oops. Seven square equals 240.34 meters. 0.5 times 9.81 times 8 square equals 313 times 92 meters. So for this object, it does not matter if it was a nickel or if it was a bowling ball. Okay, the mass does not take any account into it. This is where it would be at regarding distance for second 1, second 2, second 3, second 4, second 5. Okay, let's look at the 9th second that it's falling. 397.30 meters. 490.5 meters. Okay. Well, let's go ahead and let's look on the next column. The next column is velocity. Well, let's go on regarding velocity. Remember what we said, the first thing we said when it came to these notes on page 1. When the two vectors were falling in the same direction, velocity and acceleration, the speed picked up. Why did it pick up? Because we were adding those vectors together. Now in this case, to find velocity, we're going to get the acceleration of gravity and we're going to multiply by the second, the time that we're at. So it would be 9.81 times 2, 9.81 times 3, 9.81 times 4, 9.81 times 5, 9.81 times 6. All right? And that was the equation you were using the whole time. You were just changing the actual time or the seconds, right? Hopefully you got an answer of, the first one was done for you. You got here 19.62 meters per second, 29.43 meters per second, 39.24 meters per second, 49.05 meters per second, 58.86 meters per second, 68.67 meters per second, 78.48 meters per second, 88.29 meters per second, and then the last one was 98.1 meter per second. And then the last column over here was acceleration. Some of you got lazy and you just wrote a number. Don't do that again. Show me your math. To find acceleration, this was supposed to, remember I told everyone verbally, this was a triangle velocity divided by the amount of time. So delta t. So you got this velocity subtracted from the initial velocity, which is 0, right? Because right now here it is 0, the VI, divided by the time, so that way you can get that. So in this case, over here, what is my final velocity at this location? 19.62. Take away 0, the initial velocity, divided by 2 equals 9.81 meters per second square. Let's do this again. You're going to use this velocity, 29.43, take away the initial velocity of 0 over 3 seconds equals 9.81 meters per second square. Mathematically, it works out to where you do get the 9.81. 39.24, take away 0 over 4 seconds equals, again, 9.81. 49.05, take away 0 over 5 seconds equals 9.81 meters per second square. 58.86, take away 0 over 6 seconds equals 9.81 meters per second square. 68.67, take away 0 over 7 equals 9.81 meters per second square. And let's continue with the last few. Okay. Now we had a couple more questions down here. The one's question down here. What happens to the velocity of a falling object as it increases? What happens to the velocity of the falling object? The velocity changes and increases as time increases, right? Do we see that? As the time is changing and increasing, the velocity is changing and increasing. What happens to the acceleration of the falling object as it's increasing? As the time is increasing, the acceleration stays the same. And we can see this mathematically how it works out. It stays the same. And it does not matter. We never used any type of mass into this equation. So it doesn't matter what you're dropping. It's all going to be in free fall. And they're all going to have the same exact numbers, no matter what the mass of that object is. Alrighty, let me post this on there and I'll take pictures as well.